Now this is a wonderful question which is conceptually very challenging. It will basically highlight what is the role of a salt bridge. So clearly we can see that this NaNO3 second compartment is acting like a salt bridge. The arrangement is you have a galvanic cell, but then instead of salt bridge you are putting one more compartment, and these are porous walls through which the ions can pass. Initially the concentration of each one of them is 1 molar. This is also 1 molar, this is also 1 molar, right? And the each compartment volume is 1 liter, which means that the molarity can be assumed to be number of moles. So we need to solve these three questions, 1, 2 and 3. So basically we will just see the interchanges, what happens. So let's talk about the initial condition at the start of the reaction. What was happening in compartment 1, in 2 and 3. So in 1 we had Zn++ and its concentration was 1 molar. We had sulfate 2 minus, concentration was 1 molar. In second compartment we had Na plus, concentration was 1 molar. NO3 minus, the concentration was 1 molar. In third we had Cu++, 1 molar concentration, and sulfate correspondingly was 1 molar. This was the initial scenario in the compartment. Now what happens? Now let's see what actions are happening at electrode. Now anode is known for oxidation. Now how much amount of current is being passed? From the question we can see that passage of 0.1, matlab we are passing 0.1 farad, which means 0.1 equivalent will be liberated or deposited. So at this anode what is going to happen? Zinc is going to go in the solution as Zn++. And what is going to happen at cathode? The copper from the solution is going to deposit. So the changes, corresponding changes. So zinc plus plus will lose out what? 0.1 equivalent. Because it is divalent, it means 0.05 moles will be lost, or sorry, it will be added in the form of ions in the solution. What happens to copper plus plus? It will get deposited, so we suffer a loss over here, minus 0.05 molar. We are using moles and molarity interchangeably. Why? Because the volume of each compartment is 1 liter. This was the action which was happening at the electrode. Next what? Clearly we can see that in electrolyte the total conduction is because of what? The cations and the anions. Nothing has been mentioned about the ionic mobility, so we can see that out of 0.1 farad that is to be conducted, half of it, which means 0.05 farad will be carried by the cations and 0.05 farad will be carried by the anions, right? So what happens? In the first to second membrane we can see the transition, the Zn++ crossing over to the second compartment, and just like the beta is then passed to the sodium atom, so sodium atom is going to cross from the second to third compartment. So let's write this, the movement of the cations. So we have Zn++, it will be lost from the first compartment. How much? 0.05 farad, which means 0.05 equivalent. In terms of moles, 0.025 molar will be lost. And it is going to appear in the second compartment. It will be plus 0.025. Sodium will be lost in the second compartment because it has valency equal to 1. So it will be loss of 0.05. And this will be appearing in the third compartment as the addition of the ions, which is 0.05. Now see for the case of the anions. Anions. Sulfate is going to move from the third to second. This is the sulfate migration. And here the beta is then passed to the nitrate ions NO3 minus. Again their responsibilities are same, to conduct 0.05 farad. So what happens? In the third one, the sulfate 2 minus ions will lose out the concentration because it is doubly charged. So it is 0.05 equivalent, which means 0.025 molarity would be lost. So it is going to appear over here. SO4 2 minus is going to appear over here as plus 0.025. Nitrate, it is transitioning, it is making a movement from second to the first compartment. Valency is 1, so it is minus 0.05 molarity, and this appears over here as NO3 minus, and this would be equal to plus 0.05 molarity. This is the situation in each of the compartment. Now let us solve the questions. Now question number 1, it says the concentration of Zn++ in compartment number 1. So we have 1 molar then addition of 0.05 molar, and then the loss of 0.025. So net will be equal to what? This will be equal to 1.025. So for the first one, answer is C. Now what happens to second one? The concentration of NO3 minus in the second compartment. NO3 1 molar and then loss of 0.05. So this will be equal to 0.95, and hence the answer would be A. What about the third one? The concentration of sulfate in compartment number 3. It is 1 molar and suffering a loss of 0.075. So sulfate minus minus in third compartment will be equal to 0.975. So the molarity concentration would be 0.975, corresponding to option number D. So clearly what we can see over here, that the second compartment is playing the role of the salt bridge. It is completing the circuit as well as maintaining the neutral ions. We can very well see that if we add up all the positive concentrations and the negative concentration in each of the cell, then we will find it is neutral, it is zero, which means the charge neutrality is maintained. So it was a wonderful example highlighting the function of a salt bridge.